Hi class. In order to effectively go over this practice test, what I'm going to do is do it in 3 to 4 parts. The first part is going to be the multiple choice questions 1 through 5. The second part is going to be multiple choice questions 6 through 10. And the third part is going to be the free response questions. These will be 3 separate links on YouTube. I'm doing this so that I can take my time going through it since there is a size limit to the videos. First question says, based on the information above, what is the standard enthalpy change for the following reaction? Well, delta H, we want to use the keywords, and I don't see the word bond anywhere. I do not see a little f, so I'm going to be adding the steps. So for this reaction here, delta H is going to be equal to delta H1 plus delta H2. Looking up here, delta H1, that'll be that one, and 2, this is called X, and this is Y. Alright, so let's go through and manipulate this. We notice that SO2 is present in this subreaction, and SO2 is also present here. So we're going to have to flip the sign. So that is represented as a reactant. We also notice that there is a 2 here and a 1 here, so we're going to have to multiply that by 2. So we have minus 2x. Moving on, we see that SO3 is in this one and SO3 is here. They're both on the correct side, so we will not change the sign on Y, but we are going to have to multiply by 2. Gets rid of A, B, gets rid of C. Notice that Y is alone there. And moving these around, it's the same thing as 2y minus 2x. So the answer is E. This next question simply asks us to balance the combustion reaction shown above. And at the end, they want to know how many moles of oxygen were required. So we are going to be looking for whatever number ends up there. When it's written this way, you can get rid of that H and make that one number higher if it's easier to see. We're going to then balance it, and we're going to end up with 6 O's here and 4 here. We're going to want 10 here. However, there is already an O there, reducing that to 9 and allowing us to divide it by 2 to take care of that odd number. The answer is D. This is the combustion of propanol. Moving on to question number 3. They're asking again for a delta H value. So we're going to look for keywords. I do see the keyword bond. So we're going to use the formula delta H is equal to the sum of the bonds that are broken minus the sum of the bonds that are formed. I'm going to make sure the reaction is balanced, and actually it wasn't. We needed a 2 there. That was my bad. That should have been there. We're going to plug it in. Notice that these are the things that are broken, and the products are the things that are formed. H2 is right there. We do have one of those at 440 kilojoules required to break that. There's Cl. We do have one of those as well, 240. And we have 2 hydrochloric acids that are formed at 430 each. We're going to do this out. This is going to end up being 680. This is going to end up being 860. Immediately upon investigation, we see that this number is going to be negative. It's not going to be very big. Actually ends up being negative 180. I did forget to mention it's always a good idea to get in the habit of drawing your Lewis structures out anytime you have a reaction which uses the word bond. It's a really, really important thing to do. Moving on to problem 4. Problem 4 asks us to talk about the enthalpy the entropy and the free energy associated with the condensation of water. I know that because it's going from a gas to a liquid. Very simple question. If you think about it, in order for H2O to go to the liquid phase from the gas, it actually has to release heat. So delta H is going to be negative. In order for it to become a liquid, it actually has to get cleaner. You can think of a gas particles as being all over the place and the liquid particles as being closer together. So it is getting cleaner. That's going to make delta S negative. And delta G is a little tricky here, but they do tell you it's at 298. If you subtract 73, you're at 25 degrees Celsius. That is room temperature. At room temperature, water is a liquid. Okay, we do not drink gaseous water out of a water bottle. It's always in the liquid form. Yay. There's water. It's a liquid. That means that it spontaneously is a liquid at room temperature, making delta G negative as well. The only one that has delta G being negative all over is E. So that is the answer. Problem 5, this will be the last problem that I do on this specific YouTube clip. This is a little bit of a tricky problem, so I'm going to go through it slowly. For the reaction shown below, notice I do not show any reaction below. My bad. Let's see if we can do the problem anyway. Sorry about that. For the reaction shown below, not shown below, delta H is 50 kilojoules per mole. Let's just write that out. Delta H equals 50 kilojoules per mole. Delta S equals 100 joules per mole. Ooh, want to convert that to kilojoules. 0.100 kilojoules per mole. They seem to be doing that with delta S a lot. The question is asking us for the boiling point, so we're actually looking for T. So we're going to have to use our equation, delta G equals delta H minus T delta S, and they're solving for this. So if we plug in, we know delta H, that's 50. We know delta S, that is 0.10. We don't know delta G, so there must be some other information. Notice it tells us that there is no free energy change during a phase change. So we're talking about the boiling point, so we must be talking about the phase change of going from a liquid to a gas. That means that delta G is 0 in this case. Isolating T will give us T equals 500 degrees Kelvin, making the choice E. I'll talk to you later when we move on to number 6. Take care.